Hi everyone. Thank you for coming to another session of Math 190, Calculus 1. In this lesson, we're gonna talk about the basics of limits and what the limit is. Um, it builds up in you what the basic idea of limit. So I would name this as idea of limit. So first we gonna look at what the average velocity is, and we're going to look at um, how the average velocity is related to uh, instantaneous velocity. We're going to look at this in terms of limit, and then we're going to look at how uh, the slope of uh, the secant line becomes the slope of the tangent line at a point of a graph of a function and we're gonna talk about these things in terms of limits. So let's begin to talk about that. uh, I would take this example. An object drops from some height uh, under the gravity. First, its initial velocity is 0, and it falls down under gravity. So gravity is 9.81. So its displacement from this point, from the top location that it is released, is given by st as a function of time. S is displacement as a function of time. T is 4.9 t squared. This comes from basic equation of motions that you have already learned in physics in high school. So now when you look at this, I can draw a graph for this to represent this function. So my independent axis, or t, time, and then s of t, function, and it should go through the origin, right? It's a parabolic function like that, a curve like that. Okay, this is called s of t curve. Now we are interested in finding uh, the average velocity in between two different points. The points that I'm going to arbitrarily select is t equals 1 and t equals 2. Okay, these are the 2 points. Now, if I was to find the average velocity in between 1 and 2, t equals 1 and 2, we have here s of 2 and s of 1. So average velocity is equal to change in displacement divided by change in time, right? So if I write change in displacement s of 2 minus s of 1 divided by 2 minus 1, 2 minus 1, s of 2 is 4.9 times 2 squared, because according to this function, right here, this is this minus 4.9 times 1 squared and divided by 1, right? So the answer for that one is 14.7. If you look at that, you can calculate that and see that answer is 14.7 meters per second. Now what I'm going to do is I'm going to reduce the uh, reduce the time reference by moving this second point, or t equals 2, closer to 1. So I'm going to move it to 1.5. So from according to this average velocity, you can see that if I draw a line from 1 to 2, this is called a secant line. So the average velocity is also equal to the slope of a secant line, right? The average velocity also equal to the slope of the secant line. Now, when I move this towards 1, the secant line, the slope of the secant line changes, right? I can move it closer and closer gradually, right? And making delta t smaller and smaller, right? Smaller and smaller. When t2 equals 1.5, you get average velocity. You can calculate according to the previous equation. You can get that at 1.5, it's 12.25 meters per second. And when t equals 1.25, you get average velocity 11.05, so on and so forth, right? And that also changes, that again changes the gradient of the secant line, or the slope of the secant line. Now, when you drive this quantity delta t, which is t2 minus t1, right, from t2 is equal to closer to 1, when you drive this delta t towards 0, that means you make this, move this closer and closer to 1, you would see that the secant line would become ultimately a tangent drawn at point 1, t1, a tangent, right? So what happened is the slope, if the slope of the uh, secant line, or sorry, slope of the tangent at uh, at t1, or at t equals 1 would become limit. We call moving delta t to 0. That's how we uh, mathematically indicate that. You know, when delta t goes to 0 is mathematically written like as lim, or limit delta t goes to 0, slope of the secant line. Now the slope of the tangent line at a given point is mathematically is instantaneous velocity. which is again limit delta t goes to 0. So slope of the secant line is the average velocity. So what happened is, now you have some kind of idea about what this limit is. Limit means that you mathematically reduce some quantity or move some value towards some kind of a uh, threshold, or you make delta t equal 0. Then now what happened to the quantity? The quantity goes to some kind of constant value at the limiting condition. So in this case, we change the slope of the secant line, and the slope of the secant line ultimately becomes the slope of a tangent line. You can get any other example like velocity, you can get concentration or any other parameter for this function and get the same kind of idea. Uh, Now we're going to get a different function, a different function. Uh, Here in this case, the function is f of x equal x cube, right? F of x equal x cube. So this is an example. For an example, you get example. I get any function f of x equal x cube, x cube. Now, the slope of the secant line, if I ask to find the slope of the secant line, slope of the secant line from x equal 2 to x equal p, right? How do I find that? Well, you get which is equal to f of 2, f of p minus f of 2 divided by the difference between those 2 points in x-axis is p minus 2. Now I can write f of p is p cube minus 2 cube over p minus 2. Now from the uh, difference of cubes, we know that we can factorize p cube over 2 cube, or we can take in generally a cube minus b cube is equal to a minus b, a squared plus ab plus b squared, right? You have learned this in algebra or pre-calculus previously. So I can write the same thing here. I can write p, instead of a it's p, instead of b is 2, and I can write p squared plus 2p plus 2 squared is 4, right? And divided by p minus 2. Now that's the slope of the, okay, I can cancel these two and then you get p squared minus 2p plus 4, right? That's the slope of the secant line. Now, if I want to find the slope of the tangent line, I can find, now I have to limit, uh, hold on, let me, yeah. What do I have to do is, I have to move p towards 2, right? That means you make delta p, delta t, this is delta t goes to 0, right? Delta t goes to 0 is p2, p minus 2 goes to 0. That means p goes to 2, right? P goes to 2, we have p squared plus 2p plus 4. Now later in our later sections, you will learn that when p goes to 2, p goes to 2, you can replace that 2 p with 2, right? 4 squared plus 2 times 2 plus 4, that's 4, sorry, 2 squared, this will be 2 squared, it's 12, right? 12. So the slope of the tangent line is 12 in this case. Let's take another example. Let's take another example. That makes sense? Example. You get f of x equals x cubed, sorry, x squared plus x. Find the slope of the tangent line at x equals 0. There are two ways that we can do this problem. One is you can do this numerically. You can do this numerically. So how do we do this numerically? You can find the values of uh, delta t. So you can find, you can get uh, t1 and t2, right? T1 is now 1, 0, because I picked T1 as my point that I want to find the tangent, uh, slope of the tangent line. And here I can get a slope of the secant line. Now what we are doing is let me put another one, delta t, and then slope. So this is 0, and then you put 0.1, and the difference is 0.1, right? And then you can find f of 0, f of 0.1 minus f of 0 divided by 0.1 minus 0. F of 0 is 0. If you put 0.1, this is 0.01 plus 0.1 divided by 0.1, right? And you get 0.1, it's 1.1, right? 1.1, 1.1, 1.1. And then you can change that to, if I want to make delta t small, I put t1 0.01, then the delta t becomes 0.01. So if delta t is, hold on, I think I'm wrong. So here it's 0.01 plus 1, oh yeah, 0. And then if it is 0.01, so you can find 0.01, then this is 0.01 minus f of 0 divided by 0.01 minus 0. So this is 0.01, and then f of 0.01 is C. You can find this is point 0, 0, 0, 1 plus 0.01. You get 0.01 plus 0.0001, 0.001 plus 0.01, 0.11 divided by 0.01, So you get 1.1 in that case as well. And then this is gonna be point 001, then delta is 0.001, right? So you get 0.001 times 0.001 plus 0.001 divided by 0.001, get 1.001. Okay, so the second one is 0.01 times 0.01 plus 0.01 divided by 0.01, 1.01, 1.01. So it becomes smaller and smaller. When it goes like that, you can find the slope of the tangent line should be close to uh, close to 1. Okay, close to 1, close to 1. There's another method that you can do, that is the previous method. You can do find a p point like we previously do. So slope of the secant line from x equals 0 to x equal p, which is equal to f of p minus f of 0 divided by p minus 0, p minus 0, and then you can find the slope of tangent line at x equals 0 is equal to limit delta t goes to 0. In this case, actually, p minus 0 goes to 0. F of p minus f of 0 divided by p minus 0. In this case, this is limit p goes to 0, because p minus 0 goes to 0 means p goes to 0. And then this is p squared plus p at x 0, it is 0 divided by p. Now you can take p out as a constant, so you can get, sorry, a factor out p, and then you get limit p goes to 0, p plus 1. When p goes to 0, this quantity p becomes 0, and then you ended up with 1. So here also we obtain numerically, and this is arithmetically obtain the value. It's the same. So there are numerical methods and arithmetic methods. Let's consider another example. Fx equals tan x, and we need to find the slope of tangent line at x equal pi over 4. We consider what the range of x, pi over 4 is always taken as a close end, and then pi over 4 plus 0.01. From that we get uh, 1.98026, and then you have next point moving towards pi over 4 plus 0.001, and then you get it up with 0.99800, and then you have pi over 4 plus 0.0001. Okay, and then you get it up with 0.9980. So it goes towards 2. It goes towards 2. So these are the slopes of secant lines. And then slope of the tangent line, limit delta t goes to 0, 10 say 10p minus 10 p minus pi over 4, and that goes to 2 from the numerical table. And we can learn how to do these things arithmetically or mathematically do these things after learning a few other theories in this class. And well, that's all about of that part. So it gives you some kind of perspective what the limit is. So we look at what the idea of limit in terms of using practical application of velocity and displacement and average velocity and instantaneous velocity. Thank you very much for listening. See you in another class.